So whenever you're running Google Chrome, it will actually occupy that 1 GB of memory from your RAM. So if you have a RAM that's 8 GB, it's going to occupy 1 GB of your entire it's going to occupy that entire 1 GB, and then leave off the 7 GB to other programs. Then when you exit the Google Chrome, when you actually when you don't want to use it again and then you close it, then it's going to release that memory, that 1 GB of memory, and then that 1 GB of memory will now be available. It won't be occupied, it will be available for other programs to use. So let's actually look at different types of variables. So the variables have several different types. Just like we have to store numbers, we also have to store characters like A, B, C, D, these alphabets. Then again, characters also include the dollar symbol, the hashtag, or the pound symbol. It also includes the equals to sign on your keyboard. It also includes the question mark, this exclamation mark, and comma, full stop, and everything. But inside your computer's memory, everything is represented as binary. It won't understand anything as as we do. So computers only understand binary symbols, binary digits, which are 0 and 1. Everything is represented as 0 and 1, or strings of zeros and ones inside the memory. But like A, when we type A on our word processor like Microsoft Word, that A is going to be taken by the program, your word processor, and then it's going to be turned into a number, a decimal number like 98. So each of these characters have their own distinctive number assigned to them. But I'm going to discuss all these character types in a little while, but let me just introduce you to a new data type called int. So int necessarily means integer. So the full name is integer. Now when you were in school, or when I was in school, I used to learn about like integer is a whole number. So what is a whole number? A whole number is something that does not have any certain digit or any certain value after a decimal point. It does not include a decimal point. So an integer is something like 1, 2, 3, 10, 99, 100. So these are all whole numbers without any decimal places or any digit after the decimal place. So if we want to represent whole numbers, we need integers. So we need to tell the RAM, or we need to tell the compiler behind the scene, who's going to convert our program into binary, or it's going to it's like a translator. The compiler behind the scene, which we are not going to focus on the compiler, but the compiler is someone who's sitting in between us and the machine. So the compiler takes the program from us that we're going to write, and when we try to execute that program, the compiler is going to read that entire program, then understand it, then it's going to convert that entire program into a machine readable code. So a machine only understands, as I've told you, it only understands zeros and ones. So it only understands binary language in binary format. But we're not worried about binary, but we are worried about what's an integer. So if we want to if we want a storage space, if we want glasses, drinking cups, they are all storage spaces. So in a drinking cup, you can take water. So that drinking cup is temporarily storing water before you drink that water. or like a bottle, plastic bottle. So that plastic bottle temporarily stores water for you before you consume that water. Just like that, we need a storage space. But in this context, in our context, in the programming context, we need a name for that storage space. So a bottle is the name of the container, which is, which is in plastic, which has a cap, and it has a certain, the best example that we can have is the 100 milliliter bottle, or there might be 1 liter bottles. So let's just take the example of a 1 liter bottle. So a 1 liter bottle can actually store up to 1 liter of water inside that container. That's a container, but it has a name. The name is water bottle or mineral water bottle. And if you read the tag on the water bottle, then you will you will have an idea of how much water can it contain, or how much water can it store. So it can, if you take a bottle and it reads on the tag that it can store up to 1 liter of water, that means you can't exceed that. You can store water, like you can store up to 100 milliliter or 500 milliliter, but you can't actually exceed the range. The range is you can only store up to 1 liter of water in that container. So likewise, in this case, when we want to create a container, we need to assign a name for that container, and that is a num. In our programming context is the name of that container, and we are going to, and for this container we will be storing whole numbers. But containers need to have a specified amount that they can store. So likewise, the people who created or who made that bottle, 1 liter bottle, they designed the bottle so that it can only store up to 1 liter of water. So we need a container that can store 4 bytes of integer number. So that's a similarity that we can draw. So this data type, this is known as the data type. This int is telling the computer, or it's going to go back to the machine, and it's going to tell the machine that I need 4 bytes of space from your RAM so that I can store an integer number. And when the machine allocates 4 bytes of space, that 4 bytes of space will have a name known as num. Now you see this container which has a name called num, and it can store 4 bytes of data or 4 bytes of integer number, is actually empty. It doesn't have anything right now. So we're going to look at how that's going to work. But before we head over how to fill up our container, we need to look at how this entire format is working.